Hello everybody. Today we are going to see the problems in RLC and RLC circuit. First we will see problems in series RL circuit. For a series RL circuit whose R equal to 10 ohm and L equal to 0.25 Henry connected across a 230 volt 58 supply. Determine the inductive reactance, total impedance, current through the circuit, voltage across resistance, voltage across inductance, power factor, phase angle, active, reactive and apparent power, instantaneous voltage, instantaneous current and phasor diagram. So once the question is given, please draw the diagram. Since it is a series circuit, series R and L are connected in series, 10 ohm, 0.25 Henry, 230 volt 58 supply. So as per the question, the given data is Vrm equal to 230 volt, F equal to 58, R equal to 10 ohm and L equal to 0.5 Henry. Now as per the question, so please write down all of the things we have to find it out. So here almost we are going to find out 11 parameters. So write down the formula for each parameters. Let us start with the inductive reactance XL equal to 2 pi FL and total impedance Z equal to root of R square plus XL square. Current through the circuit IRM equal to VRMS by Z. Voltage across resistance VR equal to IRMS into R. Voltage across inductance VL equal to IRMS into XL. Power factor, that is cos phi, equal to R by Z. Phase angle pi, that is cos inverse of R by Z. Next, the power, active power, reactive power and apparent power. Active power equal to Vrms Irms cos phi. Reactive power Vrms Irms sin phi. Apparent power Vrms Irms. Then instantaneous voltage V equal to Vm sin omega t. So Vm is nothing but root 2 Vrms. Then instantaneous current I equal to Im sin omega t minus pi. So this pi indicates that it is RL load, so it is a lagging power factor. So omega t minus pi. Im equal to root 2 Irms. Next finally phasor diagram. So the total impedance Z equal to root of R square plus XL square. So we know the R value is 10 square. Then Z XL value equal to 78.5 square. So after calculating it will be 79.13 ohms. Then current through the circuit IRMS equal to VRMS by Z. VRMS is given as 230 and Z is 79.13, we got it. It is 2.90 amps. Similarly voltage across the resistance VR equal to IRMS into R, it is 2.90 into 10, 29 volts. Then voltage across inductance IRMS into XL. So IRMS we know 2.9 and XL is 278.5, that is we got it the first step, 2 to 7.65 volts. Then power factor cos phi equal to R by Z equal to 10 by 79.13, 0.12, and phase angle is cos inverse of R by Z. R is given as 10 and Z is equal to 7. So we always have a practice of writing our units for all the parameter. Next, the active power P equal to Vrms IRMS cos phi. So Vrms is 230, IRMS is cos 2.90 and cos phi is 0.12. It is 80.04 watts. So active power unit is watts. The same way reactive power calculated Vrms IRMS sin pi. So the value will be 660.33. Its unit is VAR. Next, apparent power is root of P square plus Q square. We will get Vrms IRMS. It is 230 into 2.90, 667 volt ampere. Next, instantaneous voltage Vm sin omega t. Vm we can find it out. Vm equal to root of Vrms. So that will be 325.26. So substitute all the values, we will get 325.26 sin 314t. So omega is nothing but 2 pi f. Next, instantaneous current Im equal to sin omega t minus pi. There is Im equal to Vmax by Z. So 325.26 we got it in the previous step. And then finally we got Vf 4.11. So once again substitute all the values in the formula. So Im equal to 4.11 sin omega is 2 pi f, that is 3.14, 2 pi f into 50, then pi is 82.73. Then finally power factor, phase angle, phasor diagram. So since it is an inductive load, the current lags V by pi angle. Next, a series RC circuit. For a series RC circuit whose R equal to 10 ohm, L equal to 10 microfarad, current across a 230 volt 58 supply, determine capacity reactance, total impedance, current through the circuit, voltage across a resistance, voltage across a capacitance, power factor, phase angle, active, reactive and apparent power, instantaneous voltage, instantaneous current, and a phasor diagram. So the same way how we put for RL circuit, here instead of L we have a C, 10 microfarad. So write down the given data as per the question. VR equal to 230, F equal to 50, R equal to 10, and C equal to 10 microfarad. So as per the question, so please write down the formula used for all the parameters. Capacity reactance X equal to 1 by 2 pi Fc. Total impedance Z equal to root of half square plus Xc square. So current through the circuit, voltage across resistance, voltage across inductance, power factor, phase angle, power, instantaneous voltage, everything is the same formula what we used for RL circuit. Only in case of inductive reactance, there XL, here it is XC. But the instantaneous currents will have a small variation, that is I equal to Im sin omega t plus pi, because since it is a capacitive load, so the current will be lead the voltage, so it will be plus pi. Then final phasor diagram. So as per the given data, substitute all the values, so you can find out the values for each and every. So capacity is given as 10 microfarad, it is 10 into e power minus 6. So substitute the value of C, that is 1 by 2 into 3.14 into 50 into 10 power minus, we get 3.1.4 ohms. So in the same way we find out all the values like impedance, then current through the circuit, then voltage across the resistance, voltage across inductance, power factor, phase angle. So substitute all the values as per the data given in the question, write down the formula properly, so we'll get the values correctly. So once again write down the units of the corresponding parameter. Is power, active power, reactive power, and apparent power. The same way how we find it out for RL circuit. Next, instantaneous voltage, Vm sin omega t, Vm equal to root 2 Vrms. Similarly, instantaneous current Im equal to Im sin omega t plus pi. There we used to minus, here we used to plus. So the calculations are both looks alike. So finally, phasor diagram. See here the current leads the voltage by pi angle. So the diagram is drawn accordingly. Next, series RLC circuit. For a series RLC circuit, whose R equal to 10 ohm and L equal to 0.25 Henry and C equal to 10 microfarad, connect across a 230 volt 58 supply, determine the inductive reactance, total impedance, current through the circuit, voltage across the resistance, voltage across the inductance, voltage across the capacitance, power factor, phase angle, active reactive and performance, phase diagram final. So as per the question, draw the diagram. All are connected in series. 10 ohm 0.25 into L equal to 0.10 microfarad. So write down the given data as per the question. VFRLC. So once again the same way how we solve the problem in RL. So write down the formula used for all the parameter XL, XC. So XL we know 2 pi FL, XC is nothing but 1 by 2 pi FC. But total impedance is Z equal to root of, because since we have two reactants, so inductive and capacitive, so it is root of R square plus XL square minus XC. But other formulas look alike. Voltage across resistance, voltage across inductance, power factor, phase angle, active and reactive, apparent power, final phasor diagram. So once we are familiar with RL circuit, solving the problem in RC and RLC is more or less same, only one or two parameter formula alone changes. Like for capacitance, the capacitive reactance and impedance. Similarly for RLC circuit, impedance and you have to add capacitive reactance. Other things are same. So as I mentioned earlier, use the formula properly, substitute the values from the question, you'll get XL equal to 2 pi FL. So F is 50, L is 0.25. Similarly, for capacitive reactance, 10 microfarad, that is 10 e power minus 6. So from that we find out the total impedance, we got 240.17 ohms. Then current through the circuit, Vrms by Z. Vrms is given in the question as 230 and Z we got it as 240.17. Similarly, voltage across resistance, Irms into R, and then voltage across inductance, Irms into XL, then voltage across Irms into XL. So we got R, XL and XC value in the previous line, substitute the values, we got the values. So write down the units for all the parameters. Next, we find out the power factor. that is cos pi equal to r by z, or we know 10 and z is 240.17. Substitute the values and we get the power factor. Similarly, phase angle cos inverse of r by z, so we got 87.161. And finally we have the power, different power, active power, reactive power, and apparent power. So our VRMs we know it is 230, IRMs we got it as 0.95. Substitute the values and got the active power in watts, reactive power in VAR, and apparent power in voltage. So after finding out all the things, we go for the phasor diagram. So since we have two different voltage which is caused by the three different voltage which is caused by the all three passive element, resistance, inductance, and capacitance. So since V and I are in phase with each other, so we got draw the VR and IR in the same line, but whereas the current in VC it is leading, that's why it is VC is put it in the downward side, whereas in VL the current is lag, that's why we put it in the upper point. So we got accordingly we got the VL VC, so we got the resultant voltage as VS. So based on the inductive and capacitor area, the phase angle will differ. So this way you can draw the phasor diagram. That's all. So might be there will be some typographical error. You can check with the procedure, solve the problems, you can get the solution. Thank you.